Hello, everyone. Today we are going to talk about average rate of change of a function. I'm going to put it as ARC to make it shorter. So what we see on the screen right now, it's new cases of coronavirus registered in LA County. And I'm going to use this graph to just explain what is average rate of change. Well, we see that the graph kind of has a little bump over here in the area of August 15, September 10, right? And a bigger increase over here. So, well, how do we kind of describe the fact that actually over here from December 23 to right now, the function actually grows very fast, right? And over here, for example, from August, let's say 1st to August 15, it grows, but it grows much slower. Well, we describe it using the rate of change. Rate of change is how fast something is changing. For example, over here on this graph, you can choose 2 points on the graph. For example, point 1 and point 2. And kind of calculate how much function changed over here from this date to this date. And you can say how much is changing per day or per unit of your graph. So how do we calculate this rate of change? Well, this is the change, and this is the time per which it changed. By definition, average rate of change of the function f of x is going to be, let's name this point A, and this is point B, and this is going to be f of A over here, right? And that's going to be f of B over here. So what we do, we calculate how much function changed in total over this period of time, and then divide on how long the period of time was. B minus A, and that's going to be average rate of change. For example, over here, well, I don't know what was the period in days over here because my graph doesn't show lots of dates over here, but it looks like it was 1, 2, 3, 4, 5, 6. Let me try one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, like 10 days over here. And if you choose equivalent interval over here, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, somewhere here, you are going to see that the change in y here is much smaller. You even cannot see it on the graph, but looks like a constant line, but actually there is a little change over here, just very tiny over here. And this is going to show you how fast the function is increasing. So how dangerous is it, right? And even for some regions, the function is going to show negative rate of change. Negative rate of change happens when the function is decreasing, goes down, because if you take the value over here and take the value over here and subtract from this number this, you obviously are going to get a negative number because this number, b, f of b is going to be less than f of a, and we are going to have negative rate of change. So generally speaking, rate of change shows how fast the graph is changing. For example, there is a big region on this graph where function is not changing at all. What rate of change is going to give us? 0. And over here, the very rapid increase, right? And over here, oh, there is some increase, but not that rapid as we have it right now. You see? So rate of change helps us to understand the graph. Well, we usually measure it between 2 points, or let's say on interval. And it's important which interval you choose. Let's kind of move from actual graphs to something like more mathematical. And I'm going to show you how to calculate rate of change for some real function. Example number 1, f of x equals x squared minus 5. And somebody is going to give me a equals 1, b equals 2. And they're asking, what is average rate of change on this interval from 1 to 2? Well, according to the formula, average rate of change is going to be equal f of 2, which is b, right, minus f of 1, which is a, and 2 minus 1. Now, I'm just going to substitute 2 and 1 into my function. So 2 squared minus 5 minus 1 squared minus 5 and divided over 2 minus 1. Well, here I'm going to probably open parentheses and kind of add everything. 2 squared is going to be 4, right? I'm not going to write it down like 4 minus 5 minus 1, 1 squared. And this minus and this minus are going to give me plus. And 2 minus 1 is 1, right? This minus 5 is 1. Plus 5 cancel. 4 minus 1 is 3. And 3 over 1 is going to be equal to 3. So average rate of change in this interval of this function equals 3. This is going to be same for other interval. Let's check it for a different interval. So same function, but different interval. Same f of x, but a is going to be equal 3 and b is going to be equal 4. Let's check the rate of change in this interval. Well, same way. Average rate of change equals f of 4 minus f of 3 divided over 4 minus 3. And that's going to be 4 squared minus 5, right? Minus 3 squared minus 5. And divided 4 minus 3 equals to 1, right? Now we're going to simplify it. 4 squared is 16 minus 5 minus 3 squared is 9. And minus minus is going to give me plus. And 1 over here. 5 and 5 are going to cancel. 1 was minus, 1 was plus. 16 minus 9 is going to give me what? 7 over 1. And the final answer is going to be 7. So you see that rate of change of this function is not constant. Actually, it's increasing. So function is changing faster, was farther away from like 0, right? Okay. Well, maybe I'll consider one more example of the same function, but I'm going to choose different points. I'm going to write down same f of x, but I'm going to use a equals -2 and b equals -1. Let's check what is going to happen here. Okay, so average rate of change is going to be f of -1 minus f of -2 -1 -1 is -2. Sorry, supposed to be 2 minuses here, and I wrote only 1. -2, right? Well, the formula tells that we have to subtract -2. Now, f of -1 is going to be what? -1 squared minus 5 minus -2 squared minus 5. And in denominator, well, I'm going to just simplify it a little bit, write down +2. Now, -1 squared is 1, -5, -2 squared is 4. So -4 minus and minus is going to give me plus. And over here, I'm going to just get 1. 2 minus 1 is 1. So what I'm going to get here, this cancels. 1 minus 4 is -3 over 1 is going to give me -3. And my rate of change is the same as it was in example 1, but negative. The function is decreasing and the function is kind of getting smaller, goes down. Okay, well, very good. Now, guys, we're going to talk a little bit about linear functions. Linear functions are special for rate of change because the rate of change doesn't change actually. Linear function. Well, how linear function is going to look actually? Let's give a definition. What is linear function? Linear function is going to look like mx plus c. Why we call it linear? Well, actually on the graph, it's going to look like a straight line. What is what here? M is any real number, c is any real number. Now, let's calculate a rate of change of this function in general. Just plug in the function like a general function. I'm going to prove that it's constant. So average rate of change. F of b minus f of a divided over b minus a. So mb plus c minus ma plus c. I'm just plugging b and a instead of x. Here, b minus a. Opening parentheses, mb plus c minus ma minus c, because minus going to be distributed, b minus a, and c is going to cancel, 1 positive, 1 negative, and I have mb minus ma divided over b minus a. Well, because m is the same factor in both terms, I'm going to take it outside of parentheses. And I'm going to have kind of same parentheses in numerator and denominator. I cancel them and get number m. M does not change with x. So no matter which a and b I choose, here I did not specify them. They can be 2 and 4 and 7 and 6 or whatever. My rate of change is always going to be equal m, and m is actually a coefficient of x. Okay, so for example, somebody gives you a function. Example, f of x equals minus 7x plus 2. And they say interval is a equals minus 5 and b equals 100. And instead of doing substitution into this function, you're going to say, well, that's a linear function. M equals minus 7. So my average rate of change for a linear function equals the coefficient of x, and that's going to be minus 7. You don't need to calculate anything, actually. Okay. Okay, I think that's all for this section. And basically, guys, what I want you to remember from this section, the formula for average rate of change, this one. Not very difficult, right? Change in function over change in like independent variable. And that for the linear function, average rate of change is equal to the coefficient of x. Average rate of change, it's a constant and it equals to coefficient of x. Okay, that's all, and thank you for your attention.